plus 2n plus 1. Now how many odd numbers do we have? We already had n of them here. But I put this one on, so I've got n plus 1 of them. So this up here is going to be n plus 1 squared minus 1, because it doesn't have the 1. It has the last term. It goes all the way down to 3. So this is one way of thinking about the answer. But let's do it. Let's do it another way. We have n of these things. They're 2 times 1, 2 times 2, 2 times 3, 2 times n. So I have n of these things. So how many plus 1s do I have? I have n of them, right? Okay. So I'm taking all the plus 1s and I'm handling them. N times, there's n of those plus 1s. N times plus 1 is n. Okay. Then what's left over? Well, I've got 2 times 1 plus 2 times 2 plus, that keeps on going, plus 2 times n. This last one is 2 times n. So what can we do with that? Well, I can factor out a 2. So now we have 2 times 1 plus 2 plus 3 plus n. And we know the formula for that. At least I think we know the formula for that. So this is still this plus n on the outside. That's 1/2 n squared plus 1/2 n. So I've got 2 times 1/2 n squared plus 1/2 n, then plus this n. Okay, so this is a correct answer, and this is the correct answer. We could do some algebra to check on that. Very quick. 2 times 1/2 n squared is n squared. 2 times 1/2 n is going to be n, plus another n. So we end up with n squared plus 2n. Over here, this says take n plus 1 and multiply it by itself. So n times n is n squared. N times 1, and then 1 times n, that's going to be 2n. And then finally 1 times 1. So I've got to have n squared plus 2n plus 1, and I'm subtracting a 1 off. N squared plus 2n. How about that? Okay, so you don't have to do the algebra. This is a fine answer, and so is this. And I'm happy with either. So problem 1, is that okay? Okay, moving on. So it's kind of neat that you add up the first n odd numbers that you get n squared. Let's look at the next run. So we're starting off with number 2. We're starting k, variable k off at a 1. And we have nested loops. I. Put your name on this list of people that are attending. And so we have here for I equals 0, I less than n, I plus. So this is going to execute a total of n times. From 0, we'll do something. When I is 1, we'll do something. And the last time through, I will be n minus 1. That's less than n. Then I will become n, and we won't execute whatever comes next. What comes next? Another 4. 4. J equals 0. J less than k. J plus. And what are we doing? We're doing step. Oh, and there's an open brace here. So this 4 and this step are inside of that. And in addition, the other thing we're doing is we're doing k asterisk equal 2. And that's close brace. So this 4 here applies to this compound statement. The compound statement has 2 things inside of it. This 4 applied to this step and this thing down here. Okay, so this certainly looks like another one that we need to kind of analyze step by step. So let's look at what happens when I is 0. So when I is 0, by the way, what's the value for k? So k right now is 1. So when I is 0, what's going to happen? J starts off at 0, and J executes so long as what? J is less than k, and what's k? K is 1. So yeah, we're going to execute step, and then J is going to come back up here. J will become 1. 1 isn't less than 1, so we're going to get 1 step. Okay, what else do we do? What else do we do while I is 0? Well, once this is finished, we don't go back up here yet. We go on to the next thing in this compound statement. What does this do? This makes k twice as large. So k is now going to be what? The value for k is twice 1, which is 2. Okay, so when we start out, so then we're done, and so we go back up, we make I1 larger, so I is now 2. Assume that, in something big, so 2 is less than n. So we're going to, 1 is less than n. We're going to go through here then when I is 1. Okay, what about this inside loop? Well, k is now a 2, and so when j is 0 and when j is 1, both of those are less than 2, we'll do step. So we're going to get 2 steps. And that's it, because after j is 1, j will becomes 1 larger, becomes equal to 2. Okay, what is this going to do? This is the second thing that we do is we're going to double k. So k will now, next time through, k is 4. And so when I becomes 2, we go back up, I becomes 2. 2 is again less than this big N. So yeah. Since 2 is less than the big N, we're going to do this compound statement. So we start j off over again at 0. K is 4. So we're going to get 4 steps. We'll get 4 steps. And then we're going to make k, we're going to double k. K is going to become 8. So next time through, I'm running out of room here. Next time through, I will be 3. 3 is less than this big N, and we will get 8 steps. Okay, so the total number of steps is going to be 1 plus 2 plus 4 plus 8. Notice that when I is 3, we get 3 steps. When it's like an exponent then. So when I is 0, we get 2 to the 0 or 1 step. When the exponent here, when I is 1, we get, when I is 1, we get 2 steps. When I is 2, that's over here, we get, 2 squared is 4 steps. And when I is 3, 2 cubed, that's 8 steps. So we're adding up. Okay, great. So we're adding up these powers of 2 plus, plus. What about the last time through? Well, the last time through, what's the last I? It would be n minus 1, right? It have to be less then. So so we'll have 2 to the n minus 1, and that's the number of steps we'll get. So I'll just have to write it down here that way. It's 2 to the n minus 1. We're adding up all of those, and how does that compare with our formula? 1 plus 2 plus n. You add up the first, I guess, n plus 1 powers of 2, starting off with 2 to the 0. You get the next larger power, but minus 1. So what's the answer going to be here? We could use this and subtract off something. Or you could say, well, what's the last exponent here? The last exponent is, here the last exponent was n, here the last exponent is n minus 1, but otherwise they're the same. So the result is going to be, yeah, here it was n, and we go to the next larger exponent. What's the next larger exponent? 2 to the n, right? Yeah, there we go. So we're going to calculate this value here, 2 to the n, and subtract 1. Yes, no, or... Doing it the other way, if you add on the very next term, that would be you add on 2 to the n, and that result is going to be 2 to the n plus 1 minus 1, but then that's an extra term, so I have to subtract that off. So this answer here and this answer here are the same. I don't know, do you see why? Obviously this is simpler. If you have 2 to the n plus 1, isn't that equal to 2 to the n plus 2 to the n? Think about that. This is the same as 2 times 2 to the n, or 2 to the first times 2 to the n. What's the rule if you have the same base, you add exponents? So 2 to the n plus 1 really is 2 to the n plus 2 to the n, because that's twice 2 to the n, and 1 and n makes n plus 1. Okay, so that's what this is. This is really this guy here is really 2 to the n plus 2 to the n. I'm subtracting off 1 2 to the n, so I'm left with a 2 to the n minus 1. Hey, okay. So I don't care about that part. Algebra is great. I mean, it's nice if you have two different ways of solving something, and in addition, you can figure out that there are two different correct ways of solving the problem. Okay, any questions about number 2 here? Why don't we look then at number 3? Number 3. So what do we have? We've got a triple. So for I equals 0, I less than n, I plus plus. That's first loop. Second loop, for j equals 0, j less than n, j plus plus. So these two loops, these first two loops are identical. They're starting their variable. Here's an I, here's j. They're starting them off at 0. They keep on going so long as I is less than n or j is less than n. And we what are we doing each time? We're making I one larger or making j one larger. And finally, inside of here, we've got our third loop with its variable k. K starts off at 0. We're running k so long as k is less than j, and we do k plus plus. So this is different. This here, k is, the j did not get linked up to the I. The j just varies on the n. Here though, the k is linked up to the previous variable. And then way down here we've got step. Okay. So let's take a look at this much of it. Then we'll worry about the outside loop. So we're going to count the steps here. And we can get away with that because this I, all this is doing is it's going to get it gives us n repetitions of this. So once we know what the formula is for this, each time for each different I, we start this again, and we're going to start this, and that'll happen for I being 0 all the way up through I being n minus 1. So we will start this thing here with j at 0. We'll start it n times. So whenever the answer is here, we need to multiply it by an n. So let's get the answer here. Okay, so the very first value for j is 0. So let's look at j equals 0. When j is 0, well, k, when we come down here and we make k 0, well, we run this if k is less than, so we'll get 0 steps. And
going to continue.
All right. This a very pleasant voice. Okay, next value for j is 1. Again, assuming n is something big, so 1 is less than n. And so down here, k being 0, 0 is less than 1, we're going to get one step, because then k becomes 1 larger. Instead of being 0, it'll be equal to 1. Okay, so we get one step. Then when we go back up here, j becomes 1 larger, j is 2. And so we come down here, when k is 0 and when k is 1, both 0 and 1 are less than 2. So we'll get 2 steps. But when k finally goes from 1 to 2, it's no longer less. So we get 2 steps. And that's going to, 2 steps, so when j is 3, we'll get 3 steps. Dot, dot, dot. Finally, the last time through, the last time through is when j is n minus 1. J equals n minus 1. And notice when j was 1, we got 1. When j was 2, we got 2. So we're going to get n minus 1 steps. So just, again, still working on this box, what do we have? We've got 0, which is kind of silly. I'll put it there. Plus 1, plus 2, plus 3, plus dot, 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 plus n minus 1. That's the total number of steps we're going to get from here. Again, we need to get an actual formula. We need to get rid of those plus dot, dot, dot. So that looks like to me that all that we're missing, let's see. What we're missing here is this, plus n. So that formula is a half n squared plus a half n. And we don't have that, so I better subtract off an n. So that's an answer. That's fine. So that's the answer to what's inside of this box. And what do we need to do? How many times do we repeat this box? We repeat it n times. So the total number of steps is going to be n times this half n squared plus a half n minus n. And I agree, I can combine these two things. They're both n to the first power. You can do it if you want. You're subtracting 1 from a half. What do you get? You'll get minus a half n. But you can leave it like this. And so whatever, this is what this, each time we start this 4 off of j equals 0, we get this many steps. And then how many times do we start this? We start it n times. Any questions on this one? Yes? No? No? Okay. So there's one more of these. Let's take a look at that one. Number 4, we've got 4, I starts off at 1, and we're running I so long as I is less than or equal to 2 to the n. Here I'm kind of cheating because you can't write that in C, right? 2 to the n, 2 raised to the x. So maybe we'll talk about that in a second. So while I is less than or equal to the n, I plus plus, yeah. Then what? Then we have an inside loop.
It's I times equals 2.
What?
It's I times equals 2.
Oh, times equal. Oh, cool. Okay. Yeah, I times, so I, what's happening to I? It's being doubled. Each, so yeah, I'm so used to adding, so hey, that's not happening here. Okay, but this next one is more standard. For j equals 0, j less than I, okay, j plus plus. And what we're doing step. Let's look at this. So, the very first value for I is 1. again, we're assuming n is big, so 2 to the n is big. So this middle condition is true, so 1 is less than this. So yeah, we're going to come down here, and so we're starting j off at 0 and I is 1. So we're going to get how many steps? We'll get 1 step. Okay, so over here on the keeping track of things, when I is 0, oh, sorry, when I is 1, we're going to get 1 step. And then what happens, once we finished with step, we go back up, we double I. So now I is a 2. And again, this is a really large power, and we've just got what? 2 to the first power at this point. And so, yeah, so this is true. I is less than that. So we're going to come back down here, and when j is 0 and when j is 1, 0 and 1 are both less than 2, so we're going to get 2 steps. So when we make j1 larger, the 1 becomes a 2, and it's done. So we get 2 steps. 2 steps. What's the next value? So this is now done. We go back up, we get the next value for I, which is not 3, but is what? Twice what I currently is. So I is now 4. That is basically, we've got 2 squared. And so again, this is a big number, so I is less than or equal to that. So we're going to come down here, I being a 4, and so for j being 0, 1, 2, and 3, we're going to get 4 steps. Right, so that's going to keep on happening. The next value would be 8, and that's 2 cubed. Again, think of this n as being large, and so that we're way less than that. So now we're going to get 8 steps. That continues. And the last value for I is what? 2 to the n, right? While I is less than or equal to. So we've got these dot, 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 and now we're up to where I is 2 to the n. And so that is less, it's equal, so less than or equal. We come down here. So we'll get here 2 to the n steps. Oops, no exponent, steps. Okay. So yeah, so we're going to have 1 plus 2 plus 4 plus 8 plus dot, 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 plus the last is 2 to the n. So that is the sum of these, I guess, the first n plus 1 powers, right? Because this is 2 to the 0, this is 2 to the first, 2 squared, 2 to the cube. So, and this is 2 to the 0. So this is equal to what? 2 to the next power, n plus 1 minus 1. So that's just exactly. Okay. Yeah, you can't put this in a program, but there is this thing called PAL. And so it's a function. And you plug in if that comes on, we'll look. So any question on these? I think you plug in the base and you plug in the exponent, and what PAL, so PAL returns the base raised to the x. It does the work for you. So in place of having this, we would have, maybe I've got this backwards, but I think it's base exponent. So we put in here PAL 2 comma n. That would, so that's how, you can see how that would actually be written. No, well, maybe this isn't true. I don't even, I don't want to, I was, then we want to look at these other problems on selection sort and heap sort. But let's just look at one of the days, I pull that, it's all going to come down. So all that we're going to do today is we're going to put in POW. I think it'll find it. Maybe. Zero configuration, prisoner of war. Okay, so I pronounce it POW. If it's a prisoner of war, it's a POW, right? POW, C++ reference. Fine. Okay, well,
It's loading.
yes, it's loading, but why should it be this slow?
Protect our winners.
Okay, so this is not just C++, this is also just C. Okay, so you plug in here, so here it is. You put in a base and an exponent, and they can be floating point even. Okay, and so the base goes in. The base goes in is the first, and the exponent is the second. Okay, that's all. We're finished. We just wanted to check that I was using it correctly. Please turn the lights back on. Thank you very much. Okay, so now we're moving on to talk about selection. So the first thing was to ask you to write this min position. So int min position, and it takes, so we're looking at part of an array. So we're going to be, we have a start position, a start index, and we have an end index, int end. And so here's this array. We are searching the array for the smallest possible value all the way. So the name of this array is A. So this is where the start is. We're going from here up to, including this, up to and including end. So what we're trying to do is we're trying to return the smallest value in that portion of the array. So let's look at some code here. So again, we're interested in a position. So the first position that the minimum might be is right here at start. So I'll say POS equals start. That's our first guess. That this very first place is where the minimum is. It might or might not be. So then for, you can just set up so int I. So for I equals start plus 1, while I is less than or equal to end, I plus plus, what are we going to do? We're going to check to see if A, that's the name of this array. The name of the array is A. If A brackets I is less than A brackets POS, if we found something smaller. So the position, this is where we're assuming the minimum is, and to begin with, if it's the only thing we've looked at, if we only looked at one thing, that is the minimum. But then the next place we're going to check is right over here. That would be start plus 1. So if the value at I is less than the value at A position, then I is the new smallest position. So we'll say POS is going to be assigned the value I. That's it. So this for applies to this if, and this if allows us to change the position if the value at index I is less than the position. And so then last line, then we're going to return POS, close brace. So I was looking for code somewhat like this. Yes?
Can you talk a little bit more about the first line, position equals?
Sure. Well, you need some value to start with.
Right.
Sometimes people like to start with 0, but maybe all the numbers in the array are negative. Could be. And we've got, no, so you want to start with some value that's in the array. So I started, and then we want to check all the other values. So I'm starting with, so I'm saying that this, so to begin with, I'm looking just at this value here, A brackets POS. So if that's the only value I've looked at, it's the minimum I've seen so far. So right now, the position of the minimum, the index of the minimum is start. That's why I started out that way. And then what do? The very next thing we do is we make I equal to start plus 1, and we check to see, is the value at index I, is it less than the value at POS? If it is less, we found something smaller, so that's going to be our new minimum position. Okay. So you could put up here, the minimum, conceivably all the numbers could be negative. You don't know what so you pretty much have to do something like this. Any questions on this? This is pretty much I think what we did when we looked for the maximum. We said, so this is max position, POS equals, well, with that one we always started at 0, but and then we looked at the next position, 1, and if the value at 1 was less than the value at the position, that became the new, if it was greater, if we were looking for the max. So the only difference between min and max is that you turn this around the other way. Okay, any questions on this? Other questions? Okay, well then let's, part B. You're supposed to write code that uses the min position to sort. So here's the sort from smallest to largest. So so we're supposed to sort A bracket 0 through A bracket n. And so we're going to be doing this over and over again, keeping in mind, so let me draw you a picture here. We're going to find out where the minimum is. So way over here, where the array starts, this is A bracket 0. And way over here, the last filled position of the array, so this is 0. Over here we've got A bracket end. And we want to rearrange things so that they're sorted from smallest to largest, using this thing here. So let me make kind of a schematic. What we're going to do is we're going to run this thing. So I'm going to set, I guess I'm going to have a variable I that to begin with I is going to be 0. And we're going to run this thing, this min position, min POS. We're going to run it from I up to end. So I'm plugging in. My start is I. Right now I is 0. So that part's going to change. Let me put that up just a little higher. I equals 0. That's kind of like the first step. So this is going to be returning a value. Maybe I'll call it m. So it's the minimum. And then what are we going to do? Once that tells us where the minimum is, where does the minimum belong? It belongs over here at the end. So the next step would be to swap. We're going to swap positions I, the values at positions I and m. So I'll write this out in more detail. So, to begin with I is 0. So I find out where the minimum is. I'm going to take this value and move it over here. Whatever value is here, I'm moving it here. So we're swapping the values at these two indices. Once we've done that, I'm gonna make I one larger, we do I plus plus, and we're gonna go back up and do this again. So in other words, when we get done with this, the minimum value will be here. And so now what are we looking for? We're looking for the minimum in what's left from index 1, I plus, from index 1 to the end. And then so that's going to return a value, and we'll swap those two values and go back up. We'll keep this up so long as, I guess the last time through, if I just got one thing left, it's in the correct position. So we'll keep this up while I is less than end. Okay, I'm going to write the code out over. So I'm going to erase this. Is that okay? I'm going to erase the min position. I've got kind of a plan then. So int I equals 0 while I is less than end. We're going to do a bunch of things. The first thing we're going to do is we're going to find the index of the minimum. So int m equals min position from index I up to the end. And then we're going to do the swap. So I need a temporary variable. So temp int, assuming that what the array has in it are integers, int temp equals a brackets I, and then a brackets I equals a brackets m, and a brackets m equals temp. So here's the swap. This is supposed to be a p temp. So we find out the index of the minimum. We save the index of the lowest value that we're dealing with. The value there, put it in here. We move the minimum into that lowest position. And then in where the minimum was, we put in whatever value was an I. And then we do I plus plus. Okay. So this code here, it runs min position over and over again. To begin with it runs it on the whole thing from 0 up to end. And it puts the minimum here. So I don't want to mess with this anymore. So I started off, I was 0, we ran it on the whole thing. Next time through we make I1 larger. We're looking for the minimum here from index 1 up to the end. We find the minimum there, and we put that right here. So we put the next smallest guy right here then, and we make I1 larger. And okay, does that look okay? Yeah. So that's pretty much the whole selection sort. Okay, I guess we're out of time. We'll do heap sort then. We'll talk about heap sort on Monday. Yeah. So the test. This test is what? Thursday. Oh yeah. We never have a class. This is a strange class. It meets 4 days a week. I still have, what is it, 5th week we finished now, or is it 6th week?